The X-Lyz protein assay is a simple procedure for protein quantitation in solution and solid. The reagent reacts with protein primary amines, produces a sensitive chromophore. It exhibits an absorbance covering a broad linear range of 10,000 microgram per mil. In a measurement procedure, the working reagent is simply combined with a protein sample, incubated for 15 minutes at room temperature. The color development is rapid, turning from colorless to yellow and eventually red. The experiment may be conducted in cuvettes as well as in microplates. The assay is simple and quick, has a wide linear analytical range, and its performance is highly repeatable. It requires less frequent calibration, not necessary to replot the standard curve each time. Among the different proteins that have been tested, a low level of variations was observed compared to the other commercial methods. In addition, the assay kit also provides a precipitation solution that may conveniently remove potential interfering substances in the protein samples. The X-Lyz protein assay consistently gives the accurate measurement results. For an example, as shown in the table on the right, a group of bovine serum albumin samples were analyzed. The deviations have been shown to be consistently small, and the estimates are in an excellent agreement with the true values. As mentioned in the earlier introduction slides, the X-Lyz assay covers a wide concentration range up to 10,000 microgram per mil. In comparison, other commercial methods such as BCA and Bradford assays have a limited range within only 2,000 microgram per mil. In a calibration stability study, 12 different assays were conducted over a period of 13 months. The estimation was made against the same standard curve for each assay. The deviation from the true values has been observed to be less than 10%. The X-Lyz assay has shown a low level of protein variation compared to other methods. As indicated in the table of the slide, the coefficient of variation among proteins is smaller than 10%, while commonly used Bradford-Kumassi method is as high as 44%. In addition to protein quantitation, the X-Lyz assay can also be used in other amine detection applications. For examples, determining the amount of the unblocked reactive lysine, quantitating peptides, or polyamines, monitoring proteolysis processes, and estimating cross-linking or conjugation density.